Hi, this person running through the air at almost 20 miles per hour is me, Curse Imsung. I'm doing what is called a long jump. It's an event in track and field which I love. I have been jumping ever since I could run, and I'm getting pretty good at it. Jumping is everywhere. Kids run and jump when they play, squirrels jump across tree branches, and frogs jump across lily pads. Ever since organisms could run, they could also jump. I started long jumping in middle school when I joined track, and it has quickly become my favorite event. I am currently the best long jumper in all of Bedford High School. That makes me sound like I'm really good, but in reality it's just that there aren't that many other long jumpers in the school. My current best recorded long jump is 19 feet and 3 inches. I plan to one day hold the school record for the farthest long jump. Today I want to show you the mechanics of long jump and how mathematics play a key role in conducting a successful jump. If I want that school record, then I need to have a perfect jump, and here I'll explain what that requires. But first, let's rewind, and let me explain to you what long jump actually is. Long jump, like many other events in track and field, originates from the Olympic Games in ancient Greece. The first Olympic Games, for which we still have written records, were held in 776 BCE, though it is generally believed that the games have been going on for many years already. These games were held to praise the Greek gods, mainly Zeus, the father of gods and men. The Greek city-states were constantly fighting in wars. The Olympics were held in the city of Olympia, and all wars were put on hold for the games to take place. The long jump was part of the original pentathlon events of the Olympics. Like all other original events of the Olympics, long jump was based on war. The ability to clear over obstacles was a useful skill in battle. The premise of long jump is simple. A person runs and jumps, and his distance is measured. The jump itself was made from the batter, that which is trod upon. It was a simple board placed on the stadium track, which was removed after the event. The jumpers would land in what is called escama, dug up area. Crossing over the board is considered a fault and disqualifies the jump. Jumpers would also hold telephone-shaped weights called halteres while they jumped. They would be swung forward during the jump and then thrown back to shift momentum and increase the jump length. Whoever jumped the farthest distance would be proclaimed the winner. The ancient Olympic Games continued for 12 centuries, with long jump being a very popular event. Sadly, in 393 AD, the Olympics were abolished, when Roman Emperor Theodosius I decreed that all pagan cults and practices be eliminated. However, Baron Pierre de Coubertin founded the International Olympic Committee in 1896. The modern Olympic Games brought together 14 nations and 241 athletes who competed in 43 events. One of these events was the long jump. Modern long jump is a bit different from the ancient Greek version. First of all, jumpers no longer use halteres while they jump. Competitors run down a runway and jump as far as they can from a wooden board 20 centimeters or 8 inches wide that is built flush with the runway into a pit filled with finely ground gravel or sand. If the competitor starts to leap with any part of their foot past the foul line, the jump is declared a foul, and no distance is recorded. An official is there to watch the jump and make the determination. The competitor can initiate the jump from any point behind the foul line. However, the distance measured will always be perpendicular to the foul line to the nearest break in sand caused by any part of the body or uniform. Therefore, it is in the best interest of a competitor to get as close to the foul line as possible, but not go over it. The jumper is able to take a running start down a runway before hitting the board. A jumper receives 3 jump attempts, faults or not, and the farthest jump is recorded. 3 jumps is not a lot of room for error, so it is very important that I make every jump count. It is critical when long jumping that at least one jump is perfect. What makes a good long jump, though? Let's ask my long jump instructor, Coach James.
I'm Edwin James, Bedford High School track coach. Been running track close to 20 years. Competed at high school and collegiate level. Was an arena football player. I'm out here trying to help the Bucks team get their championship. All right, long jump, what it takes to be a successful long jumper is speed, height, and a good amount of power. I've competed in sports for roughly close to 20 years. I competed in long jump in high school and college, long jump and triple jump. So when you're approaching the board, the actual runway, you want to generate a lot of speed. Speed plus height equals distance. So once you come to the launch point where you generate your speed, you hit the launch point with a high amount of power to get up into the air. Once you're in the air, you want to have successful landing. So you're stretching all your limbs out, and once you come to the ground, you let the ground catch you, as opposed to stepping in the sand. And that will entail a successful long jump. Okay, as you're approaching the board, you're getting your body ready for an explosive technique. Because what you're literally doing is you're launching your body, however much you weigh, into the air. And keep in mind, you're having to launch your body as well as taking your body from running full speed to now being suspended in flight. So it takes a good amount of power, a good amount of coordination, and a good amount of mental as well as physical strength. So once you launch into the air, your opposite leg is going to drive your jump leg up into the air. So you're taking your opposite leg, which is opposite from your jump leg. So say if you jump with your left, you're driving your right leg up, as well as you can throw your arms up, and that helps propel you into the air and gives you more hang time on your descent coming down to the sand. What's going to happen is that your body's going to naturally come at a 45-degree angle. That is ideal. So when you're running and you hit the launch point on the board, you want to jump straight up. But of course, speed is going to take you at a 45-degree angle. So you're not going to actually jump straight up. You're going to jump up, but with the speed that you're carrying, it's going to take you 45 degrees into the sand. And then gradually you'll descend. The proper way to land in the pit is to let the ground catch you, not jump into the ground. A lot of times runners will try to shove their feet into the ground, feeling like, they're scared of how natural human tendency, whenever you jump, you want to put your feet down. But there's sand in the pit, so you don't have to do that. So when you jump, you throw your body out, up and out into the air, and you let everything swing forward. That's giving you added momentum in the air. Everything that you do in long jump is to help propel you forward. So once you're in the air, you're suspended, you're throwing everything forward to give you an extra boost. Once you get that extra boost, it's going to help your jump. So on your jump, the last part of your body is being measured. So imagine jumping from one building to another. You have to clear that building. It's the same concept as long jump. You have to run as fast as you can, jump. The natural trajectory is going to curve. You're going to start at a 45-degree angle, but then it's going to curve. Once you're curving and coming down, you're going to land on that other building just like you're landing in the pit. Go Bucks.
Well, Coach James is no mathematician or physicist, but he knows what he is saying. For a successful jump, you need speed, power, and height. The reason for this is that once you launch off the board, you become a projectile. What is a projectile, you ask? A projectile is an object upon which the only force acting is gravity. Well, this isn't exactly true. You have air resistance as a force acting on you while you're in the air, but we are going to ignore this, because it is a very minuscule force, and accounting for it would make the math a nightmare. So you are a projectile. The force from the jump becomes movement, or kinetic energy. And you better make sure everything you do before and during the jump goes perfect, because once you're in the air, you can't really do much. A long jump is a perfect example of 2D projectile kinematics. When you jump, you don't turn left or right. Gravity is the only significant force on you while you're in the air, and your body can be considered a point in terms of motion. In a long jump, there are two vectors that are important, the vertical vector and the horizontal vector. The stronger the vertical vector, the longer I will stay in the air when I jump. The stronger the horizontal vector, the more distance I will cover in that air time. The trick to a good long jump is to maximize both vectors. The running start before the jump is for maximizing the horizontal aspect of the jump. The faster I run, then the faster my initial velocity will be for the horizontal part of the jump. When I hit the board, I plant my foot and pop upwards. This upwards force gives me a vertical aspect of my jump. The stronger I pop up, the higher I go. There must be a balance between horizontal and vertical initial velocity. The trick to make it balanced is so that the initial velocity of my jump is pointing upwards at a 45-degree angle. This, as Coach James said, is the ideal angle to be jumping. But why 45 degrees? 45 degrees is in between 90 degrees, where all the force is in the vertical direction, and 0 degrees, where all the force is in the horizontal direction. This balance allows for a projectile to go the farthest distance within a given velocity. Let's do some math. Alright, we're trying to figure out the farthest possible long jump I can do at my given ability, the perfect long jump. We know that for a perfect long jump, you must leave at a angle of 45 degrees, meaning I must take off at that angle, which means that my horizontal vector of velocity, let me draw that right here, and my vertical vector of velocity must be equal. They must both be the same, because if they are the same, then I will come off at a combined velocity and at is 45 degrees. 45 degrees. Because if this vector here and this vector are the same, this is coming off at 0 degrees, this is coming off at 90 degrees, they will combine and make a vector at 45 degrees, which is in the middle. So if they're the same, that means they both are, let's say, equal to v. They're both v. We don't know what v is yet, but they're both v. And this is going to be another velocity here, which will be larger than these two v's. So yes. What are these v's though? These are my velocities. So my horizontal velocity, what is that? Well, I don't have that measured because you don't time your approaches on a long jump. So when I'm running down the runway, I'm not timed when I do that. They only measure the distance. But I do have my 100-meter dash time. So I happen to run a 100-meter dash in 11.6 seconds, which is kind of fast. Not really that fast. It's all right. And I run 100 meters, so it's a 100-meter dash. And so with this, I can figure out my maximum velocity. So 100 meters over 11.6 seconds. So distance over time. So, distance over time. Let me write this here. Distance over time is equal to velocity. So this is equal to, put this in the calculator, 8.62 meters per second, about that. Yeah. 8.60 meters per second. This is my top speed. So if we're looking for the perfect jump, I'm just running as fast as I possibly can. So I run down the runway and I try to hit this speed, because this is the fastest speed I've ever ran in an event. 8.60 meters per second. So if I need to hit the board at that speed, so I'm running down and hit the board, I'm going that fast. And that is my velocity for this v. So this v is equal to, let's call these vx for the x, like horizontal, and then vy. So my vx is equal to 8.62 meters per second. So yeah. But also, Vx and Vy are equal, remember? Because I need to come off at 45 degrees. So for that to happen, Vy must also equal 8.62 meters per second. So yeah. So how do we figure out how far I jump? Well, we know that distance over time is equal to velocity, and we can easily say that you just manipulate the formula and get that distance is equal to velocity times time, right? So my distance, my long jump distance, equal to velocity times time. What is my velocity? 8.60 meters per second. That's how fast I'm going in the horizontal direction. I'm going that fast. And I don't really slow down, besides air resistance, until I hit the ground, then I abruptly stop moving. So, but what is my time though? So we have our v, but what is our time? Well, time is dependent on the vertical vector. It's how long I'm in the air for. So the faster I jump initially into the air, the longer I'll stay up there. So if I start really slow, I'm going to go like that. If I go really fast, it'll be like that. So the stronger this vector is initially, then the more air time I have. So let's calculate that. Well, the formula for height of an object, so let's write that out, is height is equal to height initial initial, plus our velocity, which is vy, because we're looking for the vertical aspect of that. So height is up, times t, which we are looking for, plus 1/2 a, which is acceleration, t squared. This is so for our in our example here, we have acceleration being gravitational acceleration. Because when you're in the air, you are a projectile, meaning the only force affecting you is the force of gravity, the force of gravitational acceleration. You're being pulled towards the ground. Because when you're in the air, you're no longer running, you're not touching the ground, so your speed, you're not like affecting your velocity at all, other than flailing around and maybe like pushing some air down, which we're ignoring air resistance. So let's rewrite this again. Our height is equal to our height initial, which we know is our height initial is 0, because we start on the ground and this ground is at a height of 0, plus vy, which we know is 8.62 meters per second. Remember, our initial velocity in that direction is 8.62. So let's write that in 8.62 times t. So t, which we are looking, what's what we're looking for, so we don't know what that is, plus 1/2 a, and I know that a is 9.8 meters per second. So acceleration, gravitational acceleration, so ag is equal to 9.8 meters per second squared. It's acceleration, remember that. So here it's going to be negative 9.8 meters per second because it is pulling us downwards. Because we're trying to, up is positive, down is negative. So we start with initial velocity as positive, but we get pulled down by the negative acceleration. And this is times t squared. Alright, so let's simplify this a bit more. Now you can say that our h is 0, because we are looking for the time it takes to do a jump. So we're looking for the time it takes to reach the ground. So we're in the air, and when we hit the ground, we want to know how long it has been. So there's going to be 2 times when we're at height of 0, when we start and when we end. And it'll make sense. So we should get 2 answers. One is 0 and one is something that's not 0, that's greater than 0. So 0, yeah, that goes away. So let's drag this out front. So 1/2 and a negative 9.8. So that's a negative 4.9 t squared plus 8.62. And look, it's a quadratic. It's a very ugly quadratic, but it's still a quadratic. So to solve for t, we need to use the quadratic equation, or quadratic formula. So let's write that out real quick. So x is equal to negative b plus or minus the square root of b squared minus 4ac, right? Yeah. All over 2a. Okay. So let's plug in our values. We know negative b. Let's change the color actually to this. Negative b, which is 8.62. Plus or minus, so plus or minus the square root of b again, 8.62 squared, for the 2, 8.62 squared minus 4ac, 4a, which is negative 4.9, c, which is 0, we don't have a c, all over 2a, negative 4.9. Okay, well, we know that 0 times anything is 0, so this just goes away. And then let's plug this into the calculator, and we get, already did that ahead of time, so yeah, just trust me on this. We get 2 answers. It's plus or minus. We know one is 0, well, obviously we knew that from the beginning, and the other one is 1.18 seconds. These are seconds. These are our time. We were looking for the roots, so that's time at height 0. So at 1.18 seconds, we are at height 0. That is important. So that is our time for how long we're in the air, our air time. So this is what we can take back and put into our original formula over here to get our distance. So let's do that. Let's do this over here. Oh. So we know that distance is equal to velocity times time. We know our velocity, our horizontal velocity, is 8.62 meters per second. So let's put that in here. 8.62 meters per second times time, which we know is 1.18 seconds. Seconds here. And now we can figure out the distance. The distance is going to be, put this in the calculator. It's about 10.17 meters. That's the distance. I don't really know how far that is. Let's put that in the feet, because I like feet a lot better. So that's 33.37 feet. Wow, that is pretty far, right? If I do everything perfectly, I can jump 33.37 feet, which is actually above the world record. Why is it so high? Well, no one's perfect. I'm not perfect. I can't actually jump 33. I could potentially jump 33.37, but if you remember from the beginning, I told you my PR is actually 19.3 feet. So yeah, that's quite a jump. That's like almost double my distance. But why is that so high? Well, I am not actually jumping at a perfect 45-degree angle. My velocities are not the same because it's impossible for them to be exactly the same. Probably my Vy is probably less than my Vx. And my Vx is not actually 8.60 meters per second. I'm not running that fast. I'm probably running slower than that because I have about 100 feet, about like 30 yards, 30 meters to get my jump in. Whereas in a 100-meter dash, I have 100 meters to get to my top speed. So that is why my potential jump is so much higher than my actual jump. But the thing is, this is the perfect long jump. So if I do everything perfect, if I run at my top speed and if I hit the board perfectly and I come off at a 45-degree angle with my Vy and my Vx being equal to each other, I could jump 33.37 feet. That's possible. It's all potential. But the thing is, it's not likely because I think the world record is about 29 feet something. So it's clearly very difficult. So long jump is all about form and doing everything right. Someone slower than me could still jump farther than me if they do their form perfectly. So it doesn't take just athletic ability to do long jump. You need to have everything right. Your vectors and your jumps, your plans. You have to be perfectly on the board. You have to hit the board perfectly and then sail across at a 45-degree angle initially and come back down with your velocity holding still. And also, yeah, there's also air resistance, which would lower these numbers, but that's very minuscule. So yeah, this is the perfect long jump. If I jump perfectly, this number here, this is the perfect long jump that I could do at my current athletic ability. So yeah, that's it.
Bart.